Hi learners, welcome back. It's week 3 and we're going to cover two learning algorithms today, Naïve Bayes and kNN. We're also going to cover some other particular types of interesting phenomenon that will serve as the basis for our understanding of basic machine learning algorithms coming into week 4 and week 5 and week 6. But just first, let's recap what we did in week 2. In week 2, we learned about concept learning. We saw that concept learning means, for example, learning a Boolean function over a particular set of training examples that might also be discrete. We saw that we could structure it as a search problem that's closer to what you might have learned in Foundations of AI, where we have to search a large space of possible hypotheses to locate the target function. We saw the idea of using a general to specific ordering and saying that a general set and a specific set basically bound and characterize the uncertainty of what the target concept might be. We saw that an active learner that could query a target concept for what it prefers or doesn't prefer, in other words, positive and negative cases, could generate informative queries and shrink the search space as a function of binary search, basically using a logarithmic number of samples to converge to the target concept. And very importantly, for later on in our course, we covered the idea of inductive bias. We saw that a learning algorithm that doesn't make any assumptions, a priori assumptions about the hypothesis is doomed to fail. It needs to see all the training examples and therefore be a rote learner that only spits back the classification that it was given during training time. In order for our learner to be able to generalize and say something new for untrained or unseen examples, it has to have a priori bias. We have to know something about the structure of the problem or assume something in order for it to generalize. So as I indicated, for this week, what we're going to do is look at two particular algorithms, Bayes rule and Naïve Bayes, as well as the k-nearest neighbor rules. So we're going to look at Naïve Bayes in the pre-lecture and k-nearest neighbors in the post-lecture. We're going to recap both of them very simply in the pre-lecture. We're also going to handle a couple of different characteristics of machine learning that are very important for you to master at this point. They're not exactly convergent with any particular part of the curriculum, but they're all important fundamental concepts. We're going to cover smoothing, which is necessary for Naïve Bayes and Bayes rule, and the idea of a cost or loss function to assess whether training or testing is working well, and the idea of noise in the case of target functions, and the problem with the curse of dimensionality, saying when we have a large space of hypotheses or inputs, it's going to make it much harder for us to learn. Let's get started now.